Coffee cools down if left in a room. Sandcastles crumble. Ink mixes with water. All these processes happen in this particular order and not the other way around. They all seem to follow a route towards disorder and higher entropy states. Watch this other video to know more about entropy. The second law of thermodynamics accounts for this tendency to increase entropy. But why does entropy tend to increase? Let's look at this ink and water system. Why does it tend to lose order and mix over time? At microscopic scales, particles are always wiggling and bumping against each other. This makes them move randomly and constantly swap positions. So, over time, particles explore all possible arrangements in space. In a glass like this one, there are around 1 septillion particles, meaning water molecules and ink pigments. So there is an incredibly huge number of possible ways to rearrange them. Each different arrangement is called a microstate. Some microstates correspond to a very different overall state of the entire glass. For example, this microstate corresponds to a mixed state, while this other one to a demixed state. Both microstates are equally likely. However, there are many more microstates that correspond to a mixed state than to a demixed state. This means that as particles rearrange and explore all the microstates, the whole glass is much more likely to be in a mixed high entropy state. So if you wait long enough, ink will spread and mix with water. Similarly, heat flows and spreads around the room instead of being concentrated in the coffee mug. And the nice ordered structure of a sandcastle crumbles down into a messy pile of sand grains. So, disordered states are much more likely than ordered states, and that determines the sequence in which things can spontaneously happen. In other words, it imposes the arrow of time. Ruled by the second law, substances tend to mix, energy tends to spread out, and structures tend to be wiped out. This raises a question: why do we see very ordered complex things like plants, animals, and cells? Well, the tendency to increase entropy applies only to isolated systems. Plants, animals, and cells are not isolated at all. They continuously exchange substances and energy with the surroundings. Living systems exploit this trick to order themselves at the expense of their surroundings. In this way, they manage to create the stunningly complex and interesting structures that we see throughout the living world. Watch other science sketches to learn more.